Meta did what they promised. They released their new open source Meta Llama 3.1, which is their 405 billion parameter model, which is huge. That's a lot of data. It's a ton of data. That's like hundreds of gigabytes, right? What an extreme amount. And it competes with the big players, right? Claude Sonnet, which is the biggest model that you can, it's actually the most advanced model that we see on the market today from Anthropic. We also have, of course, OpenAI and GPT-4 Omni, and it competes very well with those models. And guess what? You can have this model. You can download it right now. If you have a big enough GPU, you can run it there. You can quantize it, which just means making it just a little bit smaller so it can fit in the memory space of your GPU, and it works today right now. Just look at this, 405 billion. That's insane. And you can, there's a download button right there. I just think it is just amazing. And let's check out what, I mean, obviously you can do a lot with it, right? So what do you even do with these models? You can inference, right? You can fine tune, you can make them better at a specific task. You can also use search beforehand to give it more context, so that way it gives you better answers, outputs, and equality. So there's a lot of different things you can do. One of the things I was interested in was its comparison. Here, just kind of zoom in to see with the big players. I mean, if you just look at the screen here, the biggest available best models on the market today, are Claude Sonnet and GPT-4 Omni. Then you've got an open source version right here. Now you can see that it comes really close in comparisons on these benchmarks with these big players. I just think that's very it's amazing, right? Because that means that you can have this running on your own hardware, and it will be as performant in terms of the quality of output, right? Now, we do see that there are some significant, well, not really. I mean, we're starting to get diminishing returns with some of the bigger models in the case, but there are some cases where it does win in some of these benchmarks. That's really powerful. With these large language models, you can do a lot of things from a technical use case perspective. Just think about what you can do with these models. There's a lot of things, like businesses, individuals, organizations. They can use these models to perform what you normally have done on a human level. You can have these models do those things for you right now, today, and they will do as good of a job. In some cases, better. If we just take a look at some of these examples, real-time inference is one of the use cases. Now, this just means that your one human is directly interacting with the model, right? Asking it questions, getting feedback. It's helping, like, generate data, generate documents, generate articles, generate ideas. That's real-time inferencing, right? And then you've got batch inferencing. This is more along the lines of having an algorithm that interacts with the model, so that way you can achieve a whole bunch of outcomes and outputs of data using an API. So one machine's talking to another machine in front of it. And then the fine tuning is an opportunity for you to take that model and then make it your own, right? By taking the foundation of the data and then retraining it in the right way, so that way it provides you the exact output that you're looking for. And you can even get so good that it gets like 99.9% accuracy. You can do this. It's got enough data in that model. 405 billion parameters. It's more than enough to get your fine-tuning use cases to near perfect that can be any human. It's getting scary. We're in a crazy world here. Model evaluation, sure, it's a benchmark comparison. We don't need to worry about that. Who really gives much care to that other than just comparing it to you can compare it to better models. RAG is a way to provide additional context to the model. So you will typically want to add this for business data, right? So places and data that a model's never seen or has never been trained on, you can provide it context, such as private data that's behind the firewall. And here's the context. You can ask the model a question. You can give it extra context, and that will improve the outcome as well. Continual training is kind of an interesting idea, where the model gets the opportunity to learn continuously. So as you're providing it data and it provides output, you will provide it a sentiment feedback based on its response, and then you can have the model learn further down the line, which is kind of scary at the same time, because now you're giving it long-term memory. You can always use it as safety guardrails. That's kind of a neat use case, where you ask the model to evaluate the safety levels of maybe some user details like moderation, classroom safety, and if you're making announcements publicly, you want to make it can basically edit, right? It's a copy editor. You can also use these LLMs for synthetic generation, which is kind of interesting because you need to be able to generate data to train other models or for other data models in general, right, than spreadsheet models. So that's a really cool way to do that as well. Distillation recipe is another neat idea where you can use an LLM to train a smaller LLM, right? So you can use the big one to create your own tiny LLM. And the cool part about that approach is it's really cheap, right? Super cheap comparatively. And you'll be able to train the smaller model using all the knowledge from the big model to get the exact. It's kind of like a fine tuning, but better in terms of cost. It's probably a more efficient approach. Open source AI is the path forward. Blog post here from Meta. Mark Zuckerberg, founder and CEO, describes in the early days in Unix, like we would focus businesses' attentions on investing closed source versions of this. Closed source Unix, right? And that was an operating system which is necessary for foundation of providing business value to operate code on software in a secure way, like IBM and others would invest in closed source versions of Unix. And we saw eventually, though, Linux, which is the open source version, eventually gained popularity, and now it dominates from the server operational perspective, in addition to Windows, of course, which is also closed source. But Linux seems to be very common. We use Linux. We use Linux for all of our servers, every single server and every API around the world. It has essentially gained the popularity there. Oh, like it's more affordable. Yeah, because it's free. Right? It's free. That makes it nice and affordable versus the closed source Unix, which you have to pay for. Now, what's happening here is we're painting a picture, right? Paint sort of a contrast with technology closed source AI. You have to pay for it. You have to pay extra. You have to pay more money towards. But open source AI, which is what we just got in a new release today with Llama 3.1, a 405 billion parameter model, which is huge, and it creates a similar outputs to the very big players. It's amazing. So I can see why they're posting this blog and really saying, hey, open source is the way, with a model that competes with these big players. So it was Llama 2. It was like only just a little while ago. Now we got Llama 3, and then now we've got Llama 3.1 at the 405 billion parameter models, the biggest, right? Essentially the largest model available, the most performant model too. It does a really good job. And they also have some improved versions for the smaller models, so you can run them more easily on consumer devices, and they do a really good job as well from that perspective. So it is saying, hey, it's working. What we did with Unix, we're doing with AI, and we're going to see some adoption there. So why is open source AI good for developers? For software engineers, right? So we're a software engineer, and you want to be able to deploy AI, specifically in this case, large language models, into your organization, so that way you have full control. Like, what are the good benefits at having open source AI? Well, you get to have your own destination. You get to do whatever you want with this model, and then use it as much as you want. With as long as you purchase a server with enough capacity, you can use these models. You have to pay for the server, of course, pay for the hardware. The good news is you can drive your own destiny now, and you can do whatever you want, because now you can actually train and fine tune and distill your own models, which is a huge benefit towards open source, right? Every organizations need different. You need very specific goals and outcomes, and these general purpose large language models that you have to use an API to interact with in these closed source environments, you're not able to really fully take advantage of the capacity and capability of what is available from those models. You can do a lot more if you fine tune and do augment with additional data. There's just a whole bunch of things that you can do that's way better when you're using an open source model, and that you don't really have much power or control over when you're using a closed source system. Obviously, you need to protect your data, and that's a really good reason to use an open model, because now all the closed models you can only use over an API, right? Cloud over the API. So that means that you have to send all your data over to these vendors, and usually we can't do that from a security perspective. You also want to be able to compete with the level of quality And the good news is that the Llama 3.1 405 billion model really does a good job in comparing and competing with these. Essentially, you're getting almost exactly the level of performance with these big players, which is amazing. And then, of course, as these models evolve, they're going to be able to sort of snowball and accelerate and get better and better and better. And you can have more focused models in very specific cases. And that's what our current hardware allows for today. You can build a model that does exactly what you need and performs at human level or better as long as it's open source. And that's currently the only way to do it, to get that level of quality and accuracy. That's the best way to do it today, and you can only really do it with open source.